To help us with this lesson, we're excited to welcome Drew Gray, who's leading the self-driving car team at Otto, which is now part of Uber. Thanks for joining us, Drew.
You're welcome.
So Drew, can you tell us a little bit more about how you use deep learning for self-driving cars at Otto?
For sure. Deep neural networks have been a big focus in my work at Otto. We're exploring whether we can get a car to drive itself using only deep neural networks and nothing else. Sometimes we call that behavioral cloning because we're training the network to clone human driving behavior. Or sometimes it's called end-to-end learning because the network is learning to predict the correct steering wheel angle and speed using only the inputs from the sensors.
So as I understand it, deep learning isn't the only approach to building a self-driving car. For a number of years, people have been working on a more traditional sort of robotics approach. So why go with deep learning over a robotics approach?
Right. Well, my PhD is actually in control theory and artificial intelligence, so I spend a lot of time working on both approaches. In fact, engineers at Otto are working on both deep learning and the standard robotics approach. I'm working on deep learning because I think it has the potential to fundamentally change how we develop self-driving cars.
Cool. Can you explain a little bit more about the difference between the deep learning approach versus a robotics approach?
The robotics approach to building self-driving cars involves a lot of detailed knowledge about sensors, controls, and planning. With the deep learning approach, we don't have to program all that detailed knowledge into the vehicle. We simply feed all the information we have into the network, and then we let the network figure out on its own what's important. Also, deep learning allows us to build a feedback loop, where the more we drive, the more data we can collect, which in turn allows us to learn how to drive even better.
So what you're doing sounds pretty similar to what students will be doing in their final project at the end of this module, only they'll be implementing behavioral cloning in a simulator.
Well, a simulator certainly makes things easier, but the overarching principles are the same, whether you're in a simulator or a real vehicle.
Yeah, but can you actually drive a real vehicle with just a deep neural network?
You can. We actually recently drove 20 miles down the highway in San Francisco to the airport and back without touching the steering wheel once.
Wow, so it really works. Well then, let's get started building a deep neural network.
Let's do it.